So when we look back at this, we got to remember our plan from limits 2, which is our first try is just always going to be to plug in this number right in for x, because if it works, then that's all we have to do. We're done. We've got a continuous function. We're happy. So let's try that. We've got 2 divided by 3 minus 3. That's 2 divided by 0. No luck in terms of getting a finite number because we're not allowed to divide by 0. But what we can do is we can look at this and we can say we know that a finite number over 0 means there's a vertical asymptote at x equals 3. Look back at limits 2 notes if you're confused about why that's the case. So, our possible limits are plus or minus infinity or does not exist. The reason we have a vertical asymptote at the value that makes the denominator 0 is that as we put in denominators that are closer and closer and closer to 0, so let's say 2 divided by 0.1, 2 divided by 0.0001, 2 divided by 0.000001, and so on and so forth, you can see that as the denominator gets smaller and smaller and smaller, the number itself, the value, gets larger and larger and larger and larger. And if we do the same thing except with negatives, so 2 divided by negative 0.1, 2 divided by negative 0.0001, 2 divided by negative 0.000001, we can see that these numbers are getting more and more and more and more negative. We know that we can never have a value at that number that makes the denominator be 0, and you can never have a value for y because we're not allowed to divide by 0. So basically what we see is that as we sort of get closer and closer to it from each side, either the value is getting closer to positive infinity or to negative infinity, and that's what creates that vertical asymptote there. So we're trying to find an overall limit. That means we have to find the left and the right limit, just like we have before. Let's start with the right limit. Excuse me, that's the left limit, that negative. So the left means we're coming from this side. So this number here is going to be a number slightly less than 3. So a number like 2.9 or something like that. And it's not that we're figuring out the numerical value of this when x is 2.9. We simply need positive or negative because we know our answer is positive or negative infinity. We just need the sign. Is it positive or negative? So 2 is a positive. And if we put in 2.9, 2.9 minus 3, that's a small negative. And what's happening is as we get closer and closer to 3, we're going to have 2.9, 2.99999, 2.9999999, etc., etc. We're getting closer and closer to 3. But because we are inherently coming from the left, all of those numbers are going to be at least a tiny little smidgen smaller than 3. So no matter how small this gets, this denominator, it's still going to be negative, and that's what we need. So a positive number divided by a small negative number, whether it's small or not, is going to be a negative. And because it's some finite number, and it's being divided by a very, very, very small negative, it's just like what I was showing on the calculator. It's going to end up being a very infinitely large negative number. So when we do the same thing with the right limit, because we know that we're in this vertical asymptote situation, this number, because we're coming from the right, is going to be a number slightly greater than 3, like, let's say 3.1. So what we have 2 is going to be positive. And then if this is 3.1, 3.01, 3.00001, whatever, as long as it's coming from the right, it's going to be a little bit bigger than 3. So that it minus 3 is going to give us a very small positive. Positive divided by a positive is positive, and a number divided by a very, very small number is going to be infinity. Notice, though, that the limit as x approaches 3 from the left does not equal the limit that's negative infinity, that's positive infinity. So the overall limit does not exist. Okay, let's do some more practice with those ones. Pretty much all of these in the vertical asymptote section are basically the same. We just need to figure out what the sign is, and it's positive or negative infinity. Going to find the limit as x approaches negative 5 of x plus 11 over x plus 5. And again, our first step is to try to plug these in, see what we get. So negative 5 plus 11 over negative 5 plus 5, we've got 6 over 0. So that means we have a vertical asymptote. So the limits must be positive or negative infinity, or does not exist. And so to figure out which it is for the overall limit, we need the limit as x approaches negative 5 from the left, and also from the right. So we're approaching from the left, so x is going to be slightly less than negative 5. And that's going in both these spots. Negative 5.1-ish plus 11, that's going to be still positive, because 11 is way bigger. And negative 5.1 plus 5, that's negative, so we're going to have a small negative. Positive divided by negative is negative. A number divided by a very, very small number is infinity. Here, similar idea. We're approaching from the right, so that means that x is going to be slightly bigger than negative 5. Like negative 4.9 or thereabouts. Remember that when we're in the negative numbers, negative 4.9 is bigger than negative 5 because it's to the right. So a negative number, negative 4.9 plus 11, 11 is way bigger, so it's still going to be positive. Negative 4.9 plus 5, that's also a positive number, so down here is a very small positive. Positive divided by positive is positive. A number divided by an extremely small number approaches infinity. Again, overall limit does not exist. because this is negative infinity, this is positive infinity. They don't match. So let's look at an example where they do match. Find the limit as x approaches 2 of negative x over x minus 2 quantity squared. So first thing we plug in, make sure it's to both x's. Yes, we do have to plug in every time because while in this unit you know what the outcome is going to be, or in this lesson, excuse me, you don't know when you're doing the actual problem. You have to figure out which of these strategies to use. 0 squared is just 0, so that means we've got a vertical asymptote. The limit must be positive, negative, infinity, or does not exist. So, to figure out the overall limit, we do the limit as x approaches 2 from the left. We're approaching from the left, so that means that x is slightly less than 2, such as 1.9. And when we do that, we put the 1.9 in for both of the x's. Negative 1.9 is going to be a negative. Here, 1.9 minus 2 is negative, but the whole thing is squared. So a small negative squared is going to give us a negative over a small positive. So when we divide those, we have negative, a number divided by a very, very small number, infinity. Let's look at the same thing from the right so we can find the overall limit. We're coming from the right, so that means x is slightly more than 2, like let's say 2.1. So negative 2.1 would still be negative. And 2.1 minus 2 would be a small positive, but it's squared, so it's still a small positive. So exactly the same as it was up here. Negative divided by a positive is negative. Number divided by a small number is infinity. So now, in this case, these two match. The overall limit as x approaches 2 is negative infinity. Just going to write why that is. They match. So overall limit exists.